21 says the table shows the speed v of t of a runner at a given time t. So we want to make sure here we underline the word speed. So remember, speed and velocity are two different things. Speed is the unsigned magnitude, meaning just what is the value of the speed that you're running. So the numbers are always positive. And velocity is a signed quantity, meaning it's got the speed plus the direction. So it can be positive or negative. So that's important because if we do something like area, integrating speed is going to be a total area situation, whereas if you're integrating velocity, that's a net area or signed area situation. So it's important to identify that this is speed. And it says the time is given in seconds and the speed is given in meters per second. So we have a table of values. And the first question says, using correct units, interpret the meaning of the integral from 0.5 to 2 of v of t. And so this is where this is very important. So if you integrate speed, you're getting the analogous version of position. So for example, with velocity, if you integrate, you get what's called displacement, which has a signed distance, meaning you're getting the length plus the direction that you were displaced, either right or left, up or down, depending on how your direction is laid out. But for speed, when we integrate that, we're getting distance. So this is the distance, and the distance will be in meters traveled, right, from 0.5 seconds to 2 seconds. So the runner, it's how far the runner ran. So if I want to make a point here, I'm going to put this in a different color. If v of t had been velocity, then we'll call it s of t in meters. Oops. Would be displacement from 0.5 to 2 seconds. So that's an important distinction if you're doing a problem involving equations like this, is verify whether it's speed or velocity, because that has to do with signed or unsigned, and that will affect what happens when you integrate the function. All right, now B says using the left Riemann sum with 3 subintervals. So our 3 subintervals means n is 3, and they've given us the subintervals, meaning the x values where each interval starts and stops, to approximate this integral. So with Riemann sum, remember, Riemann is just simply creating rectangles and then adding those 3 rectangles. So when we add up the area of the rectangles, we need to add up their widths times their heights. So in order to calculate the width, sometimes referred to as delta x, the formula is b minus a over n. So from the integral, we can find our a to b bounds. So this is going from 2, right, starting at 0.5, and then we were given an n equals 3 in the problem. So the width of each of our rectangles will be 0.5 seconds. Then, in order to determine each of our 3 heights, right, these are the values that you would plug into the function in order to determine each of the height of your rectangles. Well, here we were told to use left endpoints. So on each of these intervals, I'm going to put a little star on the left edge, meaning these are the x values we want to extract to plug into our function. The heights of our rectangles, right, is found by plugging those values into the function, and in this case our function is named v. And rather than doing this manually by hand, we can actually pull these values off of our table. And so this is why it's important that we identify the correct x values here, because you want to grab the correct numbers here. So at 0.5, we have 4.58. At 1, if we go to our table here, we see we have 6.81. and at 1.5 we have 7.9. So those are the heights of our three rectangles. So now to compute the left-hand sum for three rectangles, we're going to get our widths of 0.5, and since all the widths are the same, you can factor it out and just sum the heights. And so we'll have 4.58 plus 6.81 plus 7.90, and this will approximate the area of our integral. Okay, so we can use an equal sign here because this is L3, this is the Riemann sum. However, the Riemann sum is not exact area, so therefore it approximates the area that the integral would give. Now you don't need to simplify this, but you can if you do type this into a calculator. These numbers add up to this, but generally speaking, you're allowed to stop at this step.